So, solving the equation, this is the stuff we started up yesterday on. So, just a couple of quick reminders, and I might even pull the notes out for this one. I think it's worthy. So, couple things to remember. We got to get the radical on one side of the equation. So, let's say we're doing number one. Good place to start is any. Whatever's over there with it has got to go away. So, one, you got to move. So that's my first thing to ponder. Once that's situated, now my job is to get rid of the square root. And again, remember your little number, your little index, your little root, if you don't see one, is a 2. And so to get rid of that, we take it to the exponent of the same value. Because those will cancel out. And if you're not sure on the squareds and things, because 8 squared is not 16, it is. And don't be scared off by large answers. Nothing wrong with a large answer. Opposite of divide is to multiply. And I can get to my solution. So really, it's just about take your time, work it through, add 6, do what you have to do. I want to do one more there. I want to see what I got coming still. Do I want to do that? I don't think I do. Because like all the rest of them on this page are kind of similar. Yeah, let's kind of keep bouncing around a little bit. I'll come back if somebody sees one. They're like, hey, do that one. I'll be like, all right. Yeah, let's do that. Let's bounce ahead a little. Because the other type that I wanted to make sure we chatted about, because I did have some questions on these yesterday. These are the ones we're actually going to like. When you get to where there's radicals on both sides, you can only have one radical per side, but one on each side is fine. So we can go ahead and square both sides, and that's just going to get rid of the radicals, period. And so now we're back to algebra 1, trying to figure out, okay, get all my n's to one side. But I will say one thing on these, and I didn't do this on number 1, and I kind of feel bad that I didn't. Before you circle and go to the next answer, remember, there are going to be some times possibly as you're doing these that when you get to your solution that it's not going to work. So you want to make sure that if you plug it back in, at the very least, you're not getting a negative radical. So like 3 minus 1 is 2. Okay, that's not negative. 8 minus 2 times 3 is 6. 8 minus 6 isn't going to be negative. That's one thing you want to watch out for, because that can kind of mess things up otherwise. But other than that, that's basically the 2 types that we ran into yesterday. Just trying to get some of those radicals set. The rest of the time that I'm going to spend, which will not be long and crazy, is going to be dealing one more time here with our graphs. So reminders, you've got 2 different types of graphs on these. And so when we're graphing, we've got square roots and we have cubed roots. I'm going to do one of each so we can kind of see. When we're doing square roots, reminder, I'm actually going to write this on here because I think it's going to come in helpful on this. You do have these in your notes if you've been taking notes. The number under the radical is my left and right movement. The number on the end by itself is going to be my up and down. Now, why does that matter? Hardy, can't I just put this in the calculator? I can, and you can, and I will on one of these. But what I want to make sure we understand is, if I understand where the shifts are right away, like here, for instance, and I might ask this when we get to the test. Okay, I'm going right 3. So what does that mean? That means my first point, I'm going to start at 0, 0. I'm going to go right 3. That's where the first point of my graph's going to be. And that's something we're going to like to know when we get to domain and range. Well, what about the rest of them? Okay, here's where you have a choice. So we talked about having a parent graph, like a starting point to work with. And then if we had a shift, right 3 is going to would be on the x-axis. So I would add 3 to each of my x values in my parent graph. But since I didn't move up or down at all, which is my y's, I would leave those all alone. There's my 3, 0 already. And I could just plot the other points. Now, if you're like, Hardy, what you just did was like some mad magic stuff. I have like no idea what you're doing. Okay, that's when we have our backup plan. So we're going to put it in the calculator instead. Square root again is second and x squared. There's my little square root logo. X minus 3. And you can absolutely pull up your chart and notice the first number right after the error messages. 3, 0. And there's 4, 1. So the calculator can do it for me. I don't have to do it on my own. But here's the last part and why I like to see the chart like this. I'd still write this chart with my numbers even if I was just using the calculator. Here's why. That first point after the error message, 3, 0, that is going to directly tell me where my domain and range are starting. There's where my domain starts at 3, forever to the right. There's where my range starts, 0, forever to the right. That first point is the key. That little guy right there. So whether you're doing the calculator or this way, I'm writing this down because it gives me so much other information that I need. Okay? That's going to be true for any radical you graph, even if it's a cube. So, I want to see something on the back here quick. Okay. I want to play with one more. Okay, I want to play with 15, because we're going to see some of this again on the review, so I don't want to drive you crazy on the last day of the week. But I do want you actually working at this, because, yeah, it's kind of tricky. Be careful. That's not a 3 I'm multiplying by. This little plus here, I'm going to actually rewrite this so we don't get fooled. Okay. So if that's my expression, can I get it on the screen if I pull back down? I'm not going to get it on. Oh, nope, I'm not going to get it on. All right. So I've got left 6 and up 3. So if I'm doing it on my own, going left 6 and up 3, there's my first dot. Now when we do cube roots, and again, this is in your notes. If you don't have them, get them from somewhere. Okay, this is my parent graph for cubes. When I go to do my movement, if I'm going this route, left and right happens the same way as the x-axis. So I'd subtract 6 from all my x's. Oofda. Oh, let's see here. But since up 3, this was x, since up 3 goes up and down like the y-axis does, my up, I'm going to add those 3 to all of my y's. So these would be the points I'm trying to graph. So you're like, Hardy, that negative 14, I can't do that. That's all right. So negative 7, 2, negative 6, negative 3, okay, negative 5, negative 5. Did I just do something stupid? I did. Oh, Hardy. I was trying to think ahead. And 2, 5. You're like, well, that's kind of weird. That kind of looks like, you know, what's the deal here? So let's see what the dealio is. Hardy, how do I do the cube thing in the calculator again? Again, it's in the notes. Math. Number 4, there's the little cube. X plus 6. The plus 3 is outside. You got to let the calculator know, whoop, I want out. Plus 3. If I graph it, there it goes, a little snake action here. It's going to keep going like this. If I pull my chart, you're never going to guess. Negative 7, 2, negative 6, 3, negative 5, 4, 2, 5. Same points. And if you remember our most favorite part about cubed roots the other day, all the arrows mean every single time, without exception. When you're doing a cubed root and you're graphing it, you could write that down before you ever graphed it and you're going to get it right. All the infinities. Got to get them on there and work those through. So, those two things, solving by roots and doing some of this graphing, that's our main focus today, because Tuesday when you come in, you're going to get a review that's going to get us ready and ready to go. We're going to spend 2 days reviewing, because this is big. There's a lot of stuff going on. Thursday. So yeah, the test will be Thursday. We will spend time on Tuesday and Wednesday making sure we have all the things ready, all the notes ready, all the questions answered, so everybody can be in fantastic shape for that test and make your grades all go up.